Hello, my name is Boris Zabitsker, and our guest today is Dr. Dominique Heger. Dominique is CEO and President of DH Technologies and Data Noobs. His companies offer a variety of big data predictive analytic consulting services and also offer predictive analytic educational courses. Today, our topic, our focus will be on challenges and methodology, technology of data preparation, preparing data, cleansing data, and preparing data for usage by machine learning algorithms. Dominique published several books where you can find a lot of useful information about data preparation, data cleansing, and machine learning algorithms, predictive analytics, deep learning, and other very interesting topics. Hi, Dominique.
Boris?
In world of machine learning, in a world of big data application development, when people use different machine learning predictive algorithms, build models, what are the biggest challenges, biggest problems typically people experience?
Well, Boris, I mean that's a really good question, obviously, and the pitfalls are basically across the spectrum. But what we're seeing actually, especially with more companies getting involved into data analytics, is really the data preparation part. Okay, so when you basically do an analysis, people focus on the actual mining part, or they use artificial intelligence to basically come up with an answer. The issue actually is that a lot of cases, a lot of scenarios actually, the data that comes in basically into your machine learning solution is not sound. Okay, so we really in the industry, I think we're struggling with the data preparation part of the equation, and what companies have to understand actually is that if the data does not get cleansed before actually being moved into the model, then it's pretty much like garbage in, garbage out.
So we're talking right now about machine learning algorithms when models should be trained.
That's
so we're not talking about Q network models, we're not talking about simulation models, we're talking about specifically machine learning algorithm training.
That's correct.
Okay.
Yes. And we always basically stipulate that we use machine learning to basically prepare the data for machine learning. Okay, so let's say you actually have a data set, and we're living in a messy world. Okay,
right.
It's just the fact that we have to deal with, and let's say you have a massive amount of data that you would like to basically analyze and mine. What companies have to understand actually is, because we'll always have missing data points.
Right.
The important thing actually is that companies really have to understand they cannot just throw them out. Okay, a lot of companies actually, they unfortunately just, if they have missing data points, they basically just throw them out.
Missing data points, yeah?
Missing data points,
Yeah, okay.
yes sir. And what happens there actually, your data set.
By the way, Dominic, missing, it means what? Because of some sensors don't send data?
Yes.
What is the cause of that?
Yes, that's correct actually. We distinguish basically, there are three different cases.
Mm-hmm.
Missing completely at random,
Okay.
missing at random, or missing not at random.
Okay.
Missing completely at random basically implies that, as you said, a sensor is not, providing data, and that's the easiest case.
Mm-hmm.
Okay. So, but even if you have missing completely at random, you cannot just throw the data points out. Okay, because your data set will actually get biased.
Mm-hmm.
Okay, so you should also not just use a single imputation method to reconstruct basically your data set, because let's say you're using a single mean imputation method. At that point, basically, while you're not really messing with the mean, the variance actually in your data set gets reduced. Okay, so you're messing basically with the variance of your data set. And if the next step in your analysis cycle is to do a principal component analysis as an example, okay, that strongly relies basically on the variance, okay, so you really actually at that point you're facing a problem because your data set now is really biased, okay, so you may get an answer, but it's probably not the answer that you want, okay. So another criteria actually is if the data is missing at random, okay, at that point basically you have a correlation basically between multiple features, okay. So as an example actually, if you do a survey on income, okay, and let's assume that men are more reluctant to talk about their income versus the women are actually more open-minded and may actually, talk about it. At that point, the missing information in the income, okay, is correlated to the gender, okay? So now you have to incorporate the gender actually factor into your data preparation analysis. So again, what we're doing at that point, we're suggesting to use multiple imputation methods, okay? So you can do multiple imputation or you can do a maximum likelihood approach to recreate that messy world that we actually live in, okay? So you're introducing actually variability back into your data set, and again, that's actually what you want, okay? Because again, we want to recreate that messy world, okay? The hardest part actually to really get done is if the data is not missing at random, okay? As an example, let's assume you're doing a study on tumors, okay? And you may actually have a lot of data for larger sized tumors, okay? It's just, it takes probably some time to detect the tumor, okay? And at that point, the tumor may already have a certain size, okay? So these data points are not missing at random, okay? It's just an artifact of the process, okay, while these data points are missing, okay. But even then, actually, you can still use a multiple imputation or a maximum likelihood, based approach to recreate that messy world and bring basically statistical relevance back into your data set, okay. So this is really an area in machine learning that we see out in the field that's lacking.
I'm just thinking by analogy. So if you think about IT environment and modeling computers, big data clusters.
Right.
Okay. So in this case, we have agent continuously collecting data.
Perpetually, yes.
With certain frequency.
Yes, sir.
Can you give an example of a problem of training data set related to IT? It will be also, let's say, probably missing data because maybe memory or overflow on our agent collection. Can you give an example on how to go around?
That's correct, actually. You still basically, even in an IT environment where you have an agent collects the data, you may still have missing data points. Okay, it could be part of the transfer when you transfer the data. Okay, but it could also be that the system is under such a heavy load. Okay, that your agent, based on the load on the nodes, is not really collecting accurate data. Okay, it may get delayed a little bit. Okay, so you still, even in an IT environment where you use an agent to collect data, you still should actually go through a statistical analysis of the data first. Okay, prior to actually moving the data set into your model. Okay, so yes, I mean, even with agents, actually, you will have outages. Okay, where you're not collecting for whatever reason or another. Okay, so again, it's the same scenario. Actually, you cannot just take the data at face value
and ignore this data
and ignore basically the step where you have to prepare it before you move it into your machine learning model.